Hello, thank you for watching this video. So in this video, we're doing question 4 of May, June 2023, question paper mathematics paper 2. And the topic is analytical geometry of circles. So I'm going to read question 4 statement and then try to answer the questions that follow. So let's go. They are saying, in the diagram, the equation of a circle centered at n is x squared plus y squared plus 24x minus 10y plus 153 is equal to 0. The equation of a circle centered at M is x plus 6 all squared plus y plus 3 all squared is equal to 25. PS and PR are tangent to the circle at M. They're saying PS and PR are tangent to the circle centered at M at S and R respectively. PR is parallel to the x-axis. K is a point on the line PS. The straight line joining N and M cuts the smaller circle at T and the larger circle at N. No problem. Let me read this thing again. They are saying, in the diagram, the equation of a circle centered at M is x squared plus y squared plus 24x minus 10y plus 153 is equal to 0. The equation of a circle centered at M is x plus 6 all squared plus y plus 3 all squared is equal to 25. PS and PR are tangent to the circle centered at M at S and R respectively. PR is parallel to the x-axis. K is a point on PS. The straight line joining N and M cuts the smaller circle at T and the larger circle at S. No problem. Let's look at this thing here. So they're saying now, you have the equations, you have a small circle centered at N, right, with the coordinates minus 12 and 5, right? And this small circle have this equation here. So this equation that you have here is the equation of a small circle. No problem. Then they're saying now, you have another circle centered at M here, this larger circle, or this bigger circle here. It have the center M, and you have this equation here that you can see. No problem. They went on to say now, PS and PR are tangents on this circle, on the larger circle. So they're saying your PS and PR are tangents, right? On the larger circle. They are tangents on this larger circle that you can see here. And they're tangent where? At R and S respectively. No problem. And then they went on to say, PR is parallel to the x-axis. What is PR? PR is one of the tangents, right? It's parallel to the x-axis. What does that mean? It means that PR have the same orientation as the x-axis. So the x-axis are horizontal, right? So this is y is equal to 0. This is x is equal to 0, right? Because this is the y-axis. Or not the y-axis, x is 0 the whole time. And this is the x-axis, and on the x-axis, y is 0 the whole time. So, the y-axis, the x-axis are horizontal, which is this line y is equal to 0 is horizontal. So, PR is parallel to the x-axis. What does it mean? It means PR is horizontal. So, they say that your PR is parallel to your x-axis, or parallel to the line y is equal to 0. No problem. What else are they saying? They are saying K is a point on PR. So K is a point on the tangent PS. What is it? Yeah. So K, which is this point here, lies on this tangent PS that you can see here. So here is your K. No problem. And then they say that the straight line joining N and M, so this straight line joining N and M cuts the small circle at T. So you have T here at this point and the large circle at S. That's what they're telling. So we're done with the statement. I hope it does make sense. I don't think I need to say it again. Or maybe, let me do. So you have a circle centered at O at N with coordinates minus 12 and 5. And you have this equation that you can see here. Here's the equation of the smaller circle. The larger circle is centered at M and have this equation here. No problem. They are saying PS and PR are tangent of a larger circle, right? So PS and PR are tangent of this larger circle that you can see here. They went on to say that your PR is parallel to the x-axis, which is your PR is horizontal. Have the same orientation as the x-axis. No problem. Then they are saying now the line that joins N and M cuts the large circle at S and the smaller circle at T. That's what they are saying. And you also have a point K that lies on the tangent PS. So that's what you have. And I think I'm done explaining it. So let's go to the question. So the first one is 4.1. They are saying calculate the coordinates of M. So they want us to calculate the coordinates of M at 4.1. So at 4.1, they want what? Coordinates of what? Of M. That's what they want. They want the coordinates of M at 4.1. What is M? M is the center of the larger circle. We're told that M is the center of the larger circle. So how are we going to find this? We're given the equation of a circle to be this. You know, the equation of a circle, its natural form or very famous form is x minus a all squared plus y minus b all squared is equal to the square of the radius, right? And a and b, which is these values here, right, are what? Are the coordinates. Are coordinates of what? Of the center of the circle. A and b are coordinates of the center of the circle. So, in this case, we're given x plus 6 and y plus 3. Or, x plus 6 all squared plus y plus 3 all squared is equal to 25. So, if we have this similar to this, we can find the coordinates of the center, which is those are the coordinates of M. If we can find the coordinates of the center of this larger circle, then we can know what the coordinates of M are. So, what am I going to do? We'll say, okay, we have x plus 6 all squared, right? Plus y plus 3 all squared is equal to 25. So, we are in this situation here. So, we want the coordinates of the center. So, how do we do that? It's easy. So, when you have this and have that, just equate this to 0 and solve for x, equate this to 0 and solve for your y. That should give you the equation of the center, the coordinates of the center. So, you say x plus 6 is equal to 0, or y plus 3 is equal to 0. So solve for x here, your x is equal to minus 6, and your y is equal to minus 3. So these values are the coordinates of the center of your circle. And your center of your circle is M, so the coordinates of M are minus 6 and minus 3. So we're done with the first question, which is 4.1. Now we'll go to the next one, which is 4.2.1. Okay, so now let's do 4.2.1. They are saying, calculate the length of the radius of the smaller circle. So, what they want us to do is to find the length of the radius of the smaller circle. What is the radius? The radius of a circle is the distance from the center of the circle to the circumference of the circle. So, they want to know this distance over here. That's what they want us to know. Right? This distance from the center to the circumference of the circle, which is from the point N, which is the center, to point T. That's what they're looking for. They want the distance. Okay, so how do we find that? When I was doing the first question, which is 4.1, I said this is the standard or the very common form of the equation of a circle, right? The equation of a circle is very commonly written in this way. It's written in the form x minus a all squared plus y minus b all squared is equal to the square of the radius. What is the radius? I said the radius is the distance from the center to the circumference of the circle. That's what the radius is. So, we do have the equation of a small circle. Here is it. It's the brown one here. So, if we can write this equation of the circle in this form, then we'll be able to see the radius or the square of the radius from writing this equation in that form. So, let's complete a square here on this equation so that it looks like this. How do we do that? Let's take this, let's write this equation here. And say we have what? X squared plus y squared plus 24x minus 10y plus 153 is equal to 0. That's what we have. So what do we do? So what we want to do, we want to complete a square. So the first thing you do when you're completing a square, right? You want to group your things together, which is this. You have x squared, you want to group it together with the one that contains x. This, you group it together with that. So you say, okay, here's my x squared, so this goes with this guy here, and this one goes with that guy over there. So we have x squared plus 24x, right? Plus y squared minus 10y plus 153 is equal to 0. So that's the first thing that you need to do. You need to rearrange or regroup these things. So x squared and 24x, x squared and 24x, y squared and minus 10y, y squared minus 10y. Then, what do you do now? So when you're here, you start applying now your rules of the square, right? What are they saying when you're completing a square? The first rule they say make sure the coefficient of x squared or your y squared in this case is 1. So the coefficient of x squared is 1. The coefficient of y squared is 1. Rule number 1 is finished. Let's go to rule number 2. What are they saying in rule number 2? Rule number 2, you transpose the constant to the right hand side. So you transpose the constant, which is this thing here, to the right hand side. So what do you do? So we will have x squared plus 24x plus 10 plus y squared minus 10y is equal to minus 153. So you transpose the constant to the right hand side. So here is on the right hand side. What is rule number 3? Rule number 3, they say add half of this and square it. So they're saying add half of the coefficient of x and add half of the coefficient of y and square. That's what you do. So what do? You say you have x squared plus 24x, right? What is half of 24? Half of 24 is 12. So you add 12, then square. They're saying add half of the coefficient of x and then square. So here's half of the coefficient. Here's coefficient of x is 24. Half of the coefficient of x is what? Is 12. Then you square it. No problem. Do the same thing on this side. You say plus y squared minus 10y. Then what are you going to do? You're going to add half of the coefficient of this, then square. What is the coefficient of y? Coefficient of y is minus 10. What is half of minus 10? It's minus 5. So you're going to add minus 5 all squared is equal to minus 153, right? Then you add these two, this and that, so that this equation balances. Because you can't just add on the left-hand side only and not on the right-hand side. Because they said add half of the coefficient of x, then square both sides. So you add it here and you add it on the other side as well. So it's going to be 12 all squared plus minus 5 all squared. That's it. Because what they say make sure the coefficient of x is 1. Then second thing, transpose the constant to the right hand side. Here is it. Then the third rule, they say add half of the coefficient of x, then square it. So you add the half of the coefficient. So half of 24 is 12. So you add 12 then square. You add it both sides. And then add half of the coefficient of y, which is minus 10. So your coefficient of y is minus 10. Then half of it is minus 5, then you add it both sides so that the equation is balanced. No problem. What is the next step? The next step, they say factorize this thing, right? They wanted to factorize the thing. So if you're factorizing it, it will be like this, all squared. You take this, take one of this, which is your x, take one of that, which is 12. Take the sign in there, so it's plus. Or maybe just take the sign of that as well. So just have 12 plus 12 here. Plus one of this is y. And then what do we have? You have minus 5 all squared. So what I'm doing, you take one and take that. So this is x, here's x, this is positive 12. he is positive 12. So it's y, he's y. It's minus 5, he's minus 5. Done. Is equal to, take the answer of that. So partial calculator minus 153 plus 144 plus 25. Let me do that on my calculator. So we have minus 153 plus 144 plus 25. So we get that this is what? This is 16. So what we have now here, we have x plus 12 all squared plus y minus 5 all squared is equal to 16. So this equation is in this form, right? This equation here is exactly in that form, which is your this and this, they represent the coordinates of the center of your equation, of center of your circle. Then that 16 there is the square of the radius. So you want the radius. So you know that 16 is r squared because this is exactly that. So this part is exactly this. This part is exactly this. This part is that part. So your r squared, which is that part, is 16 here. So you take the square root, you get that your radius is equal to 4 units. This is your radius. And you're done here. So you move to the next question, which is 4.2.2. 4.2.2. So I think I might need to clean this. So what are they saying at 4.2.2? So maybe what I can do, I can say, okay, I have the coordinates of M, right? Here's M here. Coordinates of M, we said it was minus 6 and minus 3. These are the coordinates for M. Minus 6 and minus 3. And then we get that the radius is equal to 4 units. So this distance over here is what? Is 4 units. So that the distance nt, which is 4 units, which is the radius. Because n, from n to t, you move from the center to the circumference. So nt is the radius of the circle. No problem. Then we have the coordinates which were given. So it's 5. So I've entered all this information from here into this diagram so that at least you can see the progress. What are they saying now? They are saying calculate the length of TS. They want us to find the length of what? Of TS. Where is T? T is this point on the circumference of the small circle, and S is the point on the circumference of the small, of the large circle. So they want the distance between these two circles, right? No problem. So how are we going to find this? Because they want this, they just want this small distance TS here, this distance in between these two circles. So what you can see there is that if you can find the distance, all this distance is mn, from there to there is mn. So your mn, right, is equal to, which is this entire distance here. This entire distance here is equal to what? Is equal to the ms, which is the radius of the large circle. Because the radius, the center of the large circle is m, and this is the point on the circumference s. And it also lies on that line mn. So the entire mn is equal to ms, which is this radius here. Say ms plus what? Plus ts, which is the distance that they want us to find. Plus ts plus the other thing, plus the distance tn, which we know that is 4, plus tn. That's what we can see. Mn is the entire distance, this distance over here. So this entire distance, you can get it by adding the radius here, mn, ms, and ts, and nt. That's how, it's the same thing. That's how, what you can get. So this again for the last time, the distance mn is equal to ms plus st or ts plus tn. And what we want is the distance ts. That's what we're looking for. We want this distance here. So mn, you don't have the length of mn, but you have the coordinates of m and n. So you can find that distance, right? So we can find this one. ms, can we find ms? Where is ms? Ms is the radius of this large circle. So we can find what the radius of the large circle is, because we have the equation of the big circle, and we know that this is the square of the radius. So this is the square of the radius. So r squared is equal to 25 is equal to r squared. Then we can be able to find r, so we can have a value for ms here. Ts is what we're looking for. Tn we already have Tn because Tn is the radius of the small circle, and we did calculate it here, and we found that it was 4. So in this case, we have that Tn is equal to 4 units because it's the one that we're calculating here, because it's the radius of the circle from the center of the small circle to the circumference of the small circle. So we can also find ms. Let's go and find ms. So ms is the radius of the large circle. So I said that this shape is exactly this shape here. So 25 is the square of the radius. So the square of a radius is equal to ms, because it's equal to the square of ms, which is equal to 25. Because the radius of this circle is what? Is 25. The radius of this circle is ms, right? So if you're squaring the radius, it should be equal to ms. And you know that your ms is equal to 25. Or the square of your radius is equal to 25 because this part here, right, is exactly this part. So r squared is equal to 25, right? And you know your r is ms. So you can take the square root, right, and get that your ms is equal to 5. Is equal to 5. So we have ms, we have tn. So tn is equal to 4, your ms is equal to 5, right? Then the challenge now is mn. So you have the coordinates for m, you have coordinates of n. So you can find the distance between them. So what do you say? Say the distance of mn is equal to the square root of xm minus xn all squared plus the y coordinate of m minus the y coordinate of n all squared. That's what we have. So the distance for mn is equal to the square root of what? So do we have these coordinates? Yes, we do have these coordinates. What is the x coordinate of m? The x coordinate of m is minus 6. So you say minus 6 minus y coordinate of n. Sorry, the x coordinate of n. The x coordinate of n is minus 12. So it's minus 6 minus negative 12 all squared plus y coordinate of m. Y coordinate of m is minus 3. So we have minus 3 here minus y coordinate of n. Y coordinate of n is what? Is 5 all squared. So the distance of mn is equal to the answer to that. So let's find the answer to that and see what we get. So here's the calculator. Oh, here's my calculator, my pocket. So let's find the answer to this. So the square root of minus 6 minus negative 12 all squared plus minus 3 minus 5 all squared. So you get that your mn is equal to 10 units. Equal to 10 units. So we found that this is 10 as well. So we said that there, here, that your mn is equal to what? ms plus ts plus tn. Mn, you just calculate this 10 units. It's equal to ms. What is your ms? Your ms is equal to 5. It's the radius of this large circle here. So it's going to 5 plus ts, which is what we're looking for, plus tn. Tn, what is tn? Tn is the radius of the smaller circle, which is 4. Then get that 10 is equal to this plus that is 9 plus ts. Therefore, solve for ts, you find that ts is equal to 1 unit. So your ts, which is this distance over from here, this distance from here is 1 unit. And this distance, the radius is 5 units. That's what we have. So the distance here is 4, distance between the circle is 1, and the radius of the larger circle is 5. So the entire distance between the centers of the circles is 10 units. That's what we have here. So I'm done with 4.2. Then I'm going to clean the board. And then we'll move to 4.3. So let's go. So now we're doing 4.3. So let's go. They are saying determine the equation of the tangent PR. So they want us to find the equation of this tangent PR here. So this equation here, right? No problem. So one thing that we know about this point is that about the equation. The equation is horizontal, right? So I'm doing 4.3.1. 4.3.1. We know that PR is horizontal. Why? Because it's parallel to the x-axis. We were told that PR is parallel to the x-axis. We know the x-axis is horizontal, right? You know that the gradient of horizontal points is what? It's 0. So if you have 2 points that are on the same y value, right? If you have a horizontal line, let me just say that. If you have a horizontal line, the gradient of that line is equal to 0. So the gradient of the y-axis is 0. If you can take a point here and any other point on the same line and you calculate the gradient, it will be 0. Because there is no change in the y direction. So that means the change in the y direction is 0 over whatever the change is on the horizontal, on the x-axis. So the gradient of a horizontal line is 0. So we know that this gradient of ours have a gradient of what? Of 0. That's what we know. So you want the equation of this line PR here. So you know that the equation of a line is in the form y is equal to mx plus c, right? But you know that your m is equal to 0 because your gradient is parallel to the x-axis. So, sorry, your tangent is parallel to the x-axis. So it is horizontal. So it has the gradient of 0. So you know the gradient is 0. So your equation is in the form y is equal to 0x plus c. It's equal to 0x plus c. So now, what we need to find is the value of c. C is the y-intercept. So this is the value of which, if you continue extending this value over here, that's what we need to find. The value of what? The value of c. No problem. So in order to find c, we need at least another point on this line here. What do we need? We need another point to this line. No problem. So what also do you know about tangents? So what you know about tangents is that the tangent, right, is perpendicular to what? To your radius. You know this. Tangents are perpendicular to radiuses of a circle or to the radius of a circle. A tangent is perpendicular to the radius of a circle. So this is the radius of a circle and PS is a tangent. So this tangent of yours is perpendicular to the radius of a circle. Right? Also, this one over here is perpendicular to what? To the radius of this circle, which means if I can draw a line from this circle, from the center to R, this line of ours will be perpendicular to what? It will be perpendicular to that radius. So let's draw that line. Let's draw a radius from the center, right, to our point R here. So these two are what? Are perpendicular. That you should know. That the tangent is perpendicular to the radius. Keep that in mind, which means they meet at what? At 90 degrees. That's what you should need to know. So this is horizontal, right? So the coordinates, we don't have any coordinates here. So we're trying to find the ways of getting at least the coordinates of one point on this line. So what I'm trying to find are the coordinates of R, the x and y values for R. That's what I'm trying to find. So look at this. This is horizontal, right? And it's perpendicular to what? It's perpendicular to the radius of this circle. So which means if this is horizontal and it's perpendicular to this radius of a circle, so this radius of a circle, it should be vertical, so that this radius is parallel to the y-axis. Because this line PS, is perpendicular to MS, the radius, right? And the line PR should be perpendicular to MR, the radius. Because you know the tangents are perpendicular to the radius of a circle. Right? No problem. As you can see there, it's the same situation down here. But if this one is horizontal, a tangent perpendicular to this horizontal line needs to be vertical. In the same way that the x-axis are horizontal, the y-axis are vertical. Where they intersect there, they intersect at 90 degrees. The x-axis are perpendicular to the y-axis. Because they meet at 90 degrees because one is horizontal and the other is vertical. This is a similar situation. This is parallel to the axis, so it's horizontal. And this is parallel to the y-axis because it needs to be vertical in order to be perpendicular to this one. Right? I'm done with that. So, you know that the radius of the circle is what? The radius of the circle is 5 units. Right? Because the radius of this large circle is 5 units. So this is also 5 units. So if the coordinates of M were minus 5, and if the coordinates of M were minus 5 and 3 and minus 3, from M to R, let's look at this. We're moving from M to what? To R. Right? Let's just look at this thing. You're moving from point M to point R, which is, you want to move from, because you're trying to find the coordinates of R. You are moving from point M to point R. That's what you're trying to find. So, you want the coordinates of R so that you can be able to find the equation of the circle in its full, complete form. Right? What are you going to do? You'll say, okay, from M to R, the x value does not change. Because you are stay on the same vertical line. Because if you are on a vertical line, the x value does not change. It's the same throughout the vertical line. Look at this vertical line, the y-axis. I said the y-axis, the line x is equal to 0. Because along this line, x does not change, it remains at 0. In a similar fashion, this is a vertical line as well. If x is 6 on that vertical line there, it should be 6 anywhere on that vertical line, no matter how long you extend the vertical line. Because you're not moving. In order to change the x value, you must move in the horizontal direction. But here, you don't move in the horizontal direction. You're moving in the vertical direction, which means you're moving down. So the x value will remain unchanged. Right? So from M to R, the x value does not change. It's more like you're subtracting 0 or you're adding 0 from there to there. Because there's no change. So which means what do you do? So from M to R, because this is from M to R, the x value of M, right, you are adding 0 to it. Or maybe, let's say you are subtracting 0 to it. I don't know what to do. You can say plus or minus 0, plus or minus 0. Doesn't matter. Then, or maybe, let me just say, it will remain unchanged. That will be easier. So I'm saying the x coordinate of M from here to here, it will not change because it's along the vertical line. So an x values on the vertical line do not change. That's what I want to say. I'm done with that. Now let's go to the y value. So the y value there was minus 3, right? So the y value of M was minus 3. And now you're going to move 5 units down. In order to move from the center to the radius, you must move 5 units down. Which is for the x, from the y coordinate of M, you'll be subtracting 5 units. Because from y, which is minus 3, you must move 5 units down to get this. I'm saying this down because this line is vertical, because it's parallel to the y-axis. So, in that case, from M to R, you must, on your x value of M, you must subtract 5, because you're moving 5 units down. So what you have here is y minus 5. No problem. So now, if you want the coordinates of R from M, they should look like this. So which means the coordinates for R should look like that. So it should be the x value of M, which was what? It was minus 6. And the y value of M, minus 5 units, which is y value of m was minus 3, minus 5 units. Then the coordinates of r are what? Are minus 6 and minus 8. So these are the coordinates of r. These are the coordinates of r. The coordinates for r is minus 6 and minus 8. Minus 6 and minus 8. These are the coordinates for r. Then now you have a point, you have one point on this line at least. And that one point is what? Is this one here. So you can substitute this point here and find the value of c, which some of you might see already. So you have r, you can find the value of c now. And say, okay, y is equal to 0x plus c, right? What is your y? Your y is minus 8 is equal to 0 times x, which is what? Minus 6 plus c. So it is obvious that your minus 8 plus this time this is, minus 8 is equal to, this time this is 0 plus c. Therefore your c is equal to minus 8. So your equation of a line is y is equal to 0x minus 8, or one will say y is equal to minus 8. We're done here. I could have done this very quickly, but I had to be slow just to make sure that no one is left behind. So I'm done with 4.2, which is 4.3.1. I'm going to 4.3.2. Let's go. So, let's go. What are they saying? They are saying now, at 4.3.2, determine the equation of a tangent PS in the form y is equal to mx plus c. So they want the equation of the tangent PS in the form y is equal to mx plus c. That is what they want us to find. So they want, so we have the equation of PR with this equation here. We have the equation for this line, this tangent. This tangent is y is equal to minus 8. I'm not sure where to write it. Maybe let me write it here. This y is equal to minus 8. This is the equation of the tangent PR. So now they want the equation of the tangent PS, which is this equation here. The equation of this tangent. So, how are we going to find this? I said a tangent is perpendicular to a radius of a circle. So our tangent PS is perpendicular to MS is the radius of this circle. So what do we say? We say PS is perpendicular to MS, which means this tangent of yours is perpendicular to this radius, MS. What is the reason? It's because you know that tangents are perpendicular to what? To radius of a circle. Let me just say tangent. Let me just say tangent is perpendicular to what? To radius of a circle. That is what we have there. No problem. Then, what you can do is that you can see that M, S, T, and N are collinear. They all lie on the same line. So let me write that down. So M, S, T, and N are collinear. What does collinear mean? It means that they lie on the same line. They are all on the same line. That's what that means. M, S, T, and N, they are all collinear. So what useful information does that tell you? It means that if you find the gradient between any of these 2 points, it should come out the same. Because if all points lie on the same line, a line has an equation like this. So if all of those points are all on this line, they will share the same gradient. They will have the same gradient. You can see that they all lie on the same line. Which means if you can find the gradient MS or TN or what? TN or TS or MT or whatever, the gradient between any of these 2 points should come out the same because they all lie on the same line. And the gradients, the points that lie on the same line, they all share the same gradient because They are defined by the same line. So, what do? So in that case, you want the gradient of ms, right? But you have point M, but you don't have the point S. But there's another point N there. So the gradient of what? Of MN, which is the gradient between this point, the centers of these two circles, it should be equal to what? The gradient that we want of what? Of MS. The gradient of what? Of MS. Why? These points, they are collinear points. Which is those points, they lie on the same line. So if they lie on the same line, the gradient is the same throughout of them. So what you do, let's find the gradient of MN. That gradient will be the same as that of MS. Then once we know the gradient of MS, we know that this gradient is perpendicular to this one. Therefore, the product of this gradient and the product of this gradient gives us -1. Once you get our -1, you say the product of this gradient, of the gradient of this line, and the gradient of this line should give us -1. Then we'll be able to find the gradient of this line. Once we find the gradient of the line, then we'll be able to find the equation of the line because we already have a point that lie on our tangent PS. So let's do that. So let's say we find the gradient of MN. The gradient of MN is equal to y of m minus y of n all over x of m minus x of n. What is y of m? Y of n is -3. Minus, what is y of n? Y of n is 5. All divided by x of m. What is x of m? X of m is -6. Minus x of n, which is what? Which is -12. Therefore, gradient of mn, the same as that of ms, which is that of a radius there, which is equal to the answer of this. Because I said these were equal because it's gradients between collinear points. So let's scratch this and see what we get. Say -3 minus 5 divided by -6 minus -12. Get that the gradient is equal to -4/3. So this gradient that we get is the gradient ms here. It's equal to -4/3. But we know that we know that PS is perpendicular to MS. We're given there, right? So what does that tell us? It tells that if we multiply the gradient of PS to that gradient of what? Of MS, it should give us what? -1, right? Which means that, what is the gradient of PS? The gradient of PS is what we're trying to find. So we say gradient of PS times the gradient of MS, which is what? Minus what? -4/3 is equal to -1. Equal to -1. This is what we have. Which is the gradients, which is the same thing as this. This is this. Gradient of MS is equal to -4/3, which is equal to that. It's equal to -1. So we have that this time this, which is -4/3 of PS is equal to -1. Then divide by -4/3, divide by -4/3. You get that your gradient of PS is equal to 3/4. So here's the gradient of PS is 3/4 over there. I hope this is clear. Because I said that we know that PS is perpendicular to MS. There is a reason that the tangent is perpendicular to the gradient. So we know that if we multiply the gradient of PS and that of M and give us -1, because this property belongs to perpendicular lines. Their gradients, the product of their gradients, provided one, they are not horizontal and vertical, their product would be -1. The product of the gradients of those lines would be -1 if they are not perpendicular and vertical. Then now say this times this is equal to -1. So MPS, which is this, times the gradient of MS, which is -4/3, is equal to -1. Then you solve for your gradient of PS. You find that it's equal to this, 3/4. Then, now I want the equation of a line. in the form y is equal to mx plus c. But we know our m is equal to 3 over 4, right? And then we have a point K, which has the coordinates what? This point, so we have the gradient of PS and the point there, so we can be able to find the equation of that line. So it will be K. K is what? Minus 17 and minus 5, right? So you want the value of C. What do? Say, substitute your y there, so minus 5 is equal to 3 over 4 into minus 17 plus C. Then you solve for C here. Then you find that if C is equal to not sure if I have enough space, but you're trying to solve for C, that minus 5 is equal to this plus C. So you say this times that, punch that in your calculator, minus 3 over 4 times minus 17. Okay, this is equal to minus 51 over 4, right? So this minus 51 over 4 of yours, you transpose it to this side, you add it there. So you say minus 50, you say it was minus 51. The answer of this is minus 51 over 4 because I don't have enough space. It's minus 51 over 4. This minus 51 over 4, transpose it to this side, it will become positive. So we have negative 5 plus 51 over 4. The answer is that C is equal to 31 over 4, right? So the equation of the circle is equal to, I'll write it here. The equation of the circle is y is equal to 3 over 4 x plus 31 over 4. So this is the equation of this line here. This 3 over 4 it was your gradient, which is this here, and they found C to be 31 over 4, which is that one over there. So here is the equation of TS. Done here. So I'm done with 4.3, right? I'm going to clean the board and go to 4.4. So let's clean the board. Okay, so now we're doing 4.4, right? 4.4 read as follows. They're saying quadrilateral PSM and R is drawn. Calculate the perimeter of PMSR. They're saying a quadrilateral PSMR is drawn. Calculate the perimeter of this quadrilateral. What is a quadrilateral? A quadrilateral is a four-sided shape with 4 vertices, right? So they say we have a quadrilateral P, is P, which is the vertex number 1. S, here's S here. This is the vertex number 2, right? M, where's M? M is this point here. And R, this point here. So we have this quadrilateral here, right? It looks like a kite of some sort. It is a kite actually. So we have this quadrilateral that is a kite here. No problem. They want us to find the perimeter of this shape here. What is the perimeter? The perimeter is the total length of all sides of your shape, right? So if you have a square, right? The length of this side is A, is A, is A, is A. So if you want the perimeter, it's going to be A plus A plus A plus A. So you add all these A's here. Then you'll get your parameter to be 4A, which is 4 times whatever the length that you have. If you have maybe a rectangle, then I'm saying these are equal, I'm assuming that these are equal. Let's say you have a rectangle here. So this is A, this is B, this is equal to that. So this is A, this is equal to this is B. If you want the perimeter of this thing here, you add the length of the side. You'll have A, this, A plus this one, plus B, plus this A here, and plus that B over there. So the perimeter of your rectangle will be 2a plus 2b. So this is the perimeter for your rectangle. If you have a circle, here's your circle here. So the perimeter will be the length of this outer area, like those ones. Here they call it the what? So the perimeter here, they call it what? They call it the circumference. Circumference of a circle. That's how they call it. Perimeter of the circle, they call it the circumference. To calculate it is 2 pi r. So this is what the perimeter is, right? Just the length of the outer area. So now, if you want the perimeter of this kite here, you must add all this side, and this side, and this side, and this side. That's what you should do if you want to know the perimeter. So let's do that. So I'm cleaning the board. So you might want to recall or want to remember that when you were doing grade 11, you did some tangents there on Euclidean geometry, right? I'm sure you've seen tangents like this. This tangent is this similar situation, exactly this similar situation. Let's say you have a point, a circle here, and your center O. Right? So this is equal to this. Why? Let me say A, B, C, right? So I'm saying OA, which is this distance here, is equal to OC. Why am I saying this? These are the radii of the circle. Right? These are the radii of the circle. No problem. What else do we know? You know that this angle here, which is, I'll say, is B, O, so B, this angle A, B, A, O, B, A, O, that angle there is equal to this angle here, OCB, which is equal to this angle here. It's equal to OCB, and then equal to what? 90 degrees. Why do you say that? These two are tangents, right? BA is a tangent, BC is a tangent. The tangent is perpendicular to the radius. So if the tangent is perpendicular to the radius, the angle formed by the tangent and the radius should be 90 degrees, which is this. So you say that the tangent is perpendicular to what? To the radius. No problem. What else can we say? You can say, now, this length here, BC, is equal to this length, BA, right? You say your BC is equal to what? BA. You need to know this. The distance, the tangent that come from the same external points are equal. These both of them are tangent, and they are coming from the same outside point, the same point that is outside the circle. If they're both tangent to the same circle, then those tangents of yours are equal. So what do you say? Say BC is equal to BA, right? Which is this length equal to that length. Why do you say that? These are tangents, right? From same external point. So they should be equal. So if I was giving a lesson, I was going to show how those are equal using congruency. No problem. So you need to know this. So in that case, if you're looking here, you know this is equal to this. Both of them are 5 units. So this is 5. The radius should be 5 because they are both radii of the circle. So this is 5 units and this is 5 units, right? So both of these things are radii of the circle, right? No problem. So we're 5, we're 5. Then now what we don't have this length here, which is the same as that one, because we know that this length is equal to this one, and this one here is equal to this one. So MS is called MR because they are radii of the circle. No problem. And RP is called SP because these are the tangents from the same external point. So they should be equal in length. So now, what we need to find is the length of these tangents. How are we going to do that? We have the equation of this line, right? To be what? We have the equation of the line. Let me start 4.3 here. Or maybe let me start it there. Let's start 4.3 here. So this is 4.3. No, this is 4.4.1. So, what do we have? We have the equation of PS. We found that the equation of PS was what? Was y is equal to 3 over 4 plus 31 over 4. No problem. So, this is the equation of this line. And we have the equation of this line as well. Right? We found that the equation of this line PR was equal to y is equal to 8, minus 8. So it's y is equal to minus 8. So if these functions of ours meet here, they intersect here. At the point of intersection, the coordinates are the same. The x values are exactly the same, and the y values are exactly the same at the point of intersection. If you have two functions or two lines intersecting each other, at the point of intersection, they have exactly the same gradient because at this point, the gradient, the x value is the same as that there, and the same as that there. That's what you have. So at this point P, the y value is that one over there. It's minus 8. Is minus 8. The x value is what you don't have. So at point P, you have P that lies on the line y is equal to minus 8. Because this line, we said this was minus 8 here. This line here, we said this line was y is equal to minus 8. That's what we said. So we have P that is sitting here. So we know, because this is horizontal, we know that the y value of it is minus 8 there. So we have a point that have an x value that we don't have, and the y value that we know. So we have point P, which is this. We have no the y value, we're missing the x value, because the y value is the same as that one there, because it's horizontal. Or you can just say, you can just equate this to that, because at the point of intersection, the y values are the same. So, but this is how I'm going to approach it. I'm going to say I have an x value, I want an x value, and I know the y value. So let me take this and substitute there, and then find the value at which x is equal to minus 8. So I'm going to substitute this y minus there, or equate these two, the same thing. And say, okay, minus 8 is equal to 3 over 4, x plus 31 over 4. Then transpose this to the other side. So you have minus 8 minus 31 over 4 is equal to 3 over 4 x. Find the answer to this. So have minus 8 minus 31 over 4. So we get that this is minus 63 over 4 is equal to 3 over 4x. Right? Cross multiply here. Or divide by 3 over 4. Divide by 3 over 4. So your x is equal to minus 63 over 4. Divide by 3 over 4. So your x is equal to this divided by 3 over 4. Okay, that your x is equal to minus 21. So you know that the coordinates for P is minus 21 and 8. Because you found the x now to be minus 21. So the coordinates for P is minus 21 and 8. So you have the coordinates of this point, P here. Coordinates for P to be minus 21 and 8. So now we need to find the length of a tangent. If we can find the length of this tangent here from P to R, it's the same as that because these are tangents coming from the same external point. Right? What do we do? Now we need to find the distance PR. So we know that P, I'm still continuing with that. This is all over the place. I'm still trying to continue with that question. Maybe let me continue down here. P is minus 21 and minus 8. R is minus 6 and minus 8. So the distance PR, we need to find the distance PR. Right? You know the distance formula. Or maybe you can see that these are horizontal. These are horizontal points, these ones. So you can say the distance is equal to minus 6 minus 21. Right? It's minus 6 minus 21. Which looks like 21 minus 6. Therefore, PR is equal to 5 units. 15 units, sorry. So PR is equal to 15. So you know that this is 15 units and this is 15 units. So now if you want the parameter, it will be 15 plus 15 plus 5 plus 5. So to answer the question that they wanted in the first place, which is 4.4.1, the perimeter will be equal to 15 plus 15 plus 5 plus 5, which looks like your perimeter is equal to 30 plus 10, it looks like 40. This is your perimeter. And we're done here. So, looks like we have one more question, 4.2.2. So I'm going to clean this board here and then try to answer it. Because this is 15, which is equal to that because these are tangents from the same external point. This is equal to that because these are radii of the circle. So I'm going to do 4.4.2 and we're done here. This was a bit chaotic. I've written all over the place, so but I hope it is clear to you as it is to me. So let's go. So this question 4.4 start there, then comes from there to here, then comes from here to here. There is it. That's the case I'm talking about. So we're doing 4.4.2. What are they saying at 4.2.2? They are saying now, calculate the ratio of the area of triangle NPS over the area of quadrilateral PSMR. So they want the ratio of what? Of area of your triangle NPS all over the area of quad PSMR. So they want us to divide the area of this triangle by this area of the quadrilateral. So here is this triangle here. Here is this triangle here. You can see this triangle here. So triangle NPK is N here, P is here, S is here. So that took, let me try to find another color so that we can see triangle NPS. Triangle NPS is the red one. So here is triangle NPS. Here is triangle NPS. It's this red triangle here. Right? So you know that this side is 15 units this side. I calculated that this side is equal to 15 units this side. Right? And this side is also 15 units this side down here. So this is the situation that you have. I'll just draw this situation, only the outside, the shapes only. I'll draw a triangle NPS. So triangle NPS looks like this. Is it? Is it? You have 90 degrees here, right? Because you said this is 90 degrees, so that should be 90 degrees as well. Why? Adjacent angles in a straight line. So here is it. So this is P, this is N here, and this is S down here. So it's this triangle here, right? And then also, what do we have? We also have the quadrilateral PSMR, which is P, S, you can see M is this point here. So I'll say M is somewhere here, R is down, maybe here. So here, this, and that over there. So I was trying to draw this card. Let me just draw this to be like that. So what I'm trying to do, I'm trying to redraw this kite here. So here's the situation. So this is 5, this is 5. Actually, this doesn't look good. Here's what I'm going to do. Okay, this looks better, but let me use the right color. Yeah, this looks better now. So this was 15, this is 15, this is 90 here, this is 90 here. So what I've drawn here, right, is exactly what you saw here. This and this kite over here. But I want it to be clear. So this is 5 units, this is 5 units, this is also 5 units if you think about it. Because the radius of the circle was 4 and TS was equal to 1 unit. So from S to N is 5 units as well. That's what you need to keep in mind. So what you can do is you can have this kite of yours here so that you have 2 triangles. You have half to kite. I don't like this thing of mixing inks. I'm mixing my inks. So should be using green ink here. So this is 5 and this is 5. So I'm saying half the kite like this. You've divided the kite now. And this point down here is R here. And this point here is S according to this diagram. So this should be S here. No problem. So I'm not sure if it is easy to see, but you can say that if you look in triangle, okay. So if you're looking at these, I would not like, okay, actually, this looks, I'm not sure the most efficient way of doing this thing. Or maybe, let me find the easiest way of doing this. If you look at all these triangles, they all look exactly the same. Because look, this is 5, this is 15 units. And the height, so if you look at the red triangle, right? Look at the red triangle there. The base is 15 units, the perpendicular height is 5. Right? Look at this one. At this triangle, P, there should be M here. PSM, yeah, PSM, the triangle PSM. The base of PSM is 15. The perpendicular height is 5 units. Look at this one down here. The base is 15 units and the perpendicular height is also 5 units. So these triangles all exactly the same. They are congruent. All these triangles are congruent, right? So you can say that your triangle NPS is congruent to what? To triangle PSM, which is also congruent to what? To triangle PMR. What is the reason? Because these are right angle triangle. These are right angle triangle with the same hypotenuse of 15 units and the side of 5 units. So you have exactly equal triangles. So your area of triangle 1 is equal to the area of triangle 2, which is equal to the area of triangle 3. Area 1, which is this, is called area 2, which is this, which is called area 3, which is this. Because these are exactly the same triangles. If you calculate the area of this, it's going to come out the same as the area of the small one here. It will come out the same area as the small one there. Right? So now, if you want all these things are all exactly the same. All these areas are exactly the same. So now, if you want the ratio of the areas, you say area 1 over area of the quadrilateral. Quadrilateral is these two, which is area 2 and area 3, which is area 2 plus area 3, which is equal to what? All these things are equal. So you can just say A1 over A1 plus A1. All of them are the same. So what you have is A1 over 2A1. This and that go away. You have 1 over 2. That's what you have. So the ratio of the area of the triangle NPS to that of the quadrilateral It should be 1/2. And I hope it does make sense to you, as it does to me. I'm done with this question. Thank you for watching. Cheers.